All right, AP, here is a sample exercise 3.33. We're calculating the number of moles and mass. Cobalt is a metal that is added to steel to improve its resistance to corrosion. Calculate both the number of moles in the sample in a sample of cobalt containing 5.00 times 10 to the 20th atoms and the mass of that sample. Go ahead and press pause now because here comes the solution. So note that the sample of 5.00 times 10 to the 20th atoms of cobalt is less than 1 mole, right? We know that because we know Avogadro's number. What fraction of a mole it represents can be determined as follows. We take the information that's given to us, atoms of cobalt, that number of atoms is given to us by the question, and we can use Avogadro's number to convert that number of atoms into moles of cobalt. We generate a value of moles of cobalt. Since the mass of 1 mole of cobalt is 58.93 grams, the mass of 5.00 times 10 to the 20th atoms can be determined as follows. Okay, I take the number of moles of cobalt that I generated up here, working with it now, and I can convert the number of moles of cobalt into the number of grams of cobalt using the molar mass of cobalt given to me by the periodic table. And I generate a mass of cobalt, 4.89 times 10 to the negative 2 grams of cobalt. My reality check. In this case, the sample contains 5 times 10 to the 20th atoms, which is approximately 1,000th of a mole by a factor of 3 zeros there. Okay, three exponents. Thus, the sample should have a mass of about 1,000th of the mass of a mole of cobalt, which is 58.93 grams. And so, a little quick calculation is going to be about 0.06. About, not exactly, but again, we're not trying to do anything difficult here to give ourselves a reality check. So our answer of about 0.05, right? It's not exactly, we're just rounding here. Makes sense. And again, when I do things like rounding, taking broad strokes, this is just for my reality check. This is just to give myself confidence in my mind that I am doing something wrong now, doing something right. Now, if I come up with a number that is wildly different than this 1,000th of the mass that I come up with, like if it's like half the mass, that should be a red flag that you did in fact do something wrong. You're going to have to recalculate your response.